computer engineering department, what professor are we talking about? Well, there's lots of possibilities there, right? So the functional dependency doesn't work the other way. So again, the way that we would phrase this is A determines B, or B is functionally dependent on A. Okay, so one of the steps in our normalization process we talked about to go to the second normal form was based on this idea of the full functional dependency. So a full functional dependency exists if a column or set of columns is dependent on some other set of columns, but not on any subset. Okay, so if it's functionally dependent on this set of columns, but it's also functionally dependent on a subset, so staff number alone determines branch number, then this example is not a full functional dependency, because we don't need this extra column. It's like extra information. We don't need all that in order to determine what the branch number is, if all we really need is the staff number alone. Okay. All right. So then the other type of dependency that we talked about that is part of our normalization process is identifying these transitive dependencies. And the idea here is that if A determines B and B determines C, okay, then what we can do is we can kind of break B and C off into their own table, so that we don't have to keep C we don't have to make it dependent on A. Okay, we already know that it's dependent on A, so we don't have to have C and A be in the same table. And the reason why all this is important is because where we were getting to is I'm going to skip and then come back for a second, because what we're trying to do, let's see, is we're trying to make our database and the tables in our database less vulnerable to these update anomalies. So the idea is we don't want redundant information. All right, we don't want to have to store the same data more than once. We want to be able to just store things once if possible. Hold on a second, I just realized something. Yeah, good. Yeah, okay, thank you for talking about the recording. So whoever started the recording, that was exactly what I was coming over here to check, because I realized that I did not click on to start the recording. So thank you for whoever took care of that. All right. Okay. So because that recording is going to be automatically uploaded to the stream once this meeting is over. So that's where we want it to be. All right. So anyway, so we were talking about this whole update anomalies. If we store things more than once, then the problem that we could run across is what happens if somehow it gets changed in one place but not the other, and so we'll end up with data information that is that's invalid, or you might say it's corrupted or something like that. Okay, so that's what we're trying to avoid. All right. So if we look back at this example here, I'm going to come back to this sample data information. So a couple of easy ones that we can look at here was we could say, okay, well, the value in column A and the value in column C seem very closely related. Every time that A appears here, I see a Z or a Z here. Okay, and the same is true in every row that an A appears here, I can know what C is. E is R every time. And it also works both ways, right? So which one is the strong one? We don't really know just from this sample data. Okay, so unlike if we look back at the staff number, staff name, I won't go back to that slide, but if we talk about that staff number, staff name, one of those, so in an existing data set, it might always be that staff number and staff name have this one-to-one relationship. It's always the same. But we would use our human intuition to say it seems like staff number determines staff name all the time, whereas staff name, we may end up with two staff members who happen to have the same name at some point in the future, so it may not always be that staff name determines staff number. Okay, whereas with data like this example data, it's harder for us to come up with a which one is stronger, which one is the more for all time type of thing. Okay, and so then let's look at another example, this functional dependency 3 here, that B determines D. Now, it doesn't mean that if that multiple values in B can't have the same value in D. So here's an example right here where both the value of B and the value of D here have the same value of W over here. Okay, and that's okay. It's just the only thing that's important is if some value here appears, then it should have the same value here when it happens. So B has a W, B also has a W. D has a W, D also has a W. So F results in the S over here. Now what we need to do when we start identifying these functional dependencies is we need to make sure we include all columns. And so we need to figure out, how does E work into all this? Now, does E determine something over here? No, it doesn't really appear that there is a consistent E determines anything over here, because a value of Q here, well, it's always W in D, but T in the E column has a couple of different values. Okay, so E doesn't determine D, E doesn't determine C, because Q could be a Z or Q could be an R. Okay, so maybe E is determined by some other set of columns. As we talked about in the recorded video, the A column alone doesn't do it, because a value of A here does not always end up with the same value over here in E. Okay, so maybe if we combine two columns together, we can find something over here. Now, what we end up doing is we end up combining A and B, because in our example data here, every row has a different combination of A and B together. So this is never, A and B does not appear again. If there's an A here, it doesn't appear a B over here again. So because this is distinct, this is unique across every row, the combination of the A and B column, then what that means is that A and B alone is a unique pairing of columns for all the rows. So what you end up with is that it's a pretty good chance that that could be a primary key or a candidate key. All right. So the way that then we would look at this data and we would write out the functional dependencies, is we would write them out to look like this, where A determines C, but C also determines A. B determines D, and then A and B determine E. Now, I said that we want to make sure that we have a functional dependency that involves every column. So we want to have at least one functional dependency that we want to basically have all of the columns appear at some point in our functional dependency list. Okay, so all 5 columns, A, B, C, D, and E, all appear somewhere. That doesn't mean that certain columns can't appear more than once. So obviously, like A here appears multiple times, B here appears multiple times. Okay, so that's okay. We just want to make sure that we cover all the columns in our table. Okay. So as we start getting into how we're going to use these functional dependencies to normalize our database, so if we take an unnormalized form, or what we'll refer to as UNF, okay, we're just going to create this unnormalized data. We just take the data from whatever source it comes from, and we bring it into a table format. So I'm going to kind of go back and forth a little bit between here and my my vaccine trial example. So I'm going to see I'm going to share the other one here. Okay. I'm going to share my desktop. I think that should work better. Okay. So now, if I'm not mistaken, you guys should be seeing this vaccine trial example. Figured it might be something that we might all be interested in right now, that it's kind of on our minds. So the idea here is that here I have an unnormalized database. Make sure you let me know if you can't see this, if this is not coming through like I think it should be. Okay. So what we have is we just have the data put in here into a grid type of format. So one of the things you'll notice is that here we can look at this data and understand what this means, that there's this implied that Joseph Ledet appears with both this set of information but also this set of information. Okay. The problem is that a database table, a database management system, it can't make that kind of intuitive understanding. We have to let it know. We have to force each of these rows to have this information duplicated. So what that is, what we would call that when we do that, and we would call that the first normal form. So here basically what I've done is I've taken the same information and I've just brought it into the first normal form. I've just taken this, I've copied this information into here so that it's more clear to the DBMS what's going on, like why this information is as it is. Okay, so the first normal form, its official definition would be just a relation, a table in which every intersection, every row column contains one and only one value. Just as we've talked before, one and only one value. It can be a string, it could be a number, it can be a date, it can be lots of different types of things. It's just a value of some kind. Okay. All right, so basically first normal form's pretty easy. One of the things that the first normal form you can identify is what would your primary key be, a candidate key or a primary key for that, because since every row, right, so every row column has a single value, it means we have this set of rows and they're all unique. So in this example there's 9 columns. So every row, there's no duplicates, so there's no there's some difference between this row and this row. Okay, in this particular example, you see there's a difference here, there's a difference here. Okay, so that would be first normal form. We can identify a primary key. For those of you who watched the recorded video, you know that we talked a little bit through this. How do you identify what the primary key is well, anything that's duplicated across more than one row cannot possibly be a primary key on its own. So the fact that we have more than one patient ID of 123 says the column patient ID on its own cannot be the primary key. Same thing with drug ID. This appears multiple times. Drug name, date given. Oh, it's two examples of that. Right, given by ID, all of that. Okay, so clearly there's no single column that can be a primary key on its own. So what we need to do is we need to determine, okay, what can be then? What combination of columns can get us to a unique identifier for the row? So we could do this, right? So we might be tempted to think, well, maybe patient ID with drug ID. But the problem is that then you've got this and this combination, right? Where someone, Jim Morrison, was given both the CV1, whatever that is, drug at 2 different dates. All right. Okay. So what we end up deciding is, what I ended up deciding based on this example data is that a good primary key would be the combination of patient ID and date given. Now, if we look across this, all right, the same patient does not ever get treated on the same day more than once. Okay, so is that valid? Is that going to hold for all time? Don't really know. I mean, this is not a real drug trial, so clearly I don't know how those things really work, but it seems like it's not a terrible assumption to make on a drug trial situation. So one thing I noted is that if you wanted to include, and I highlighted it in yellow here, that the drug ID, that we might say, well, a patient may come in twice on the same day, but not be given the same drug twice on the same day. Okay, yeah, if you want to include that, that's okay. There's nothing wrong with that. And for each of you, for your group projects, it's going to be different for whatever your data is. Which let me take this moment to also reiterate something that I wrote a comment about. I've had a couple of people ask me this question. When I say 30 data items, I mean 30 columns. Okay, so when the group assignment description talks about 30 data items, it means you need to have 30 of these columns. So like this example has 9. So your group project is going to have just over 3 times as many data columns here. Okay. All right, so that would be the first normal form. We have every row, column, intersection has a single piece of information. And then we also go ahead and define what our primary key is. So for this example going forward, we're going to continue with this patient ID date given combination be our primary key. Okay. So again, that's what we did, was we removed repeating groups, and we identified what the primary key was. So the second normal form is we want to only have full functional dependencies that exist in all of our tables. So if we look at our example here, you'll notice that not everything is fully functionally dependent on the primary key. So this is fully functionally dependent. You know, if we have the combination of this and this, it's going to be that. But here, patient name and patient surname, I don't need the combination of patient ID and date given in order to know what that is. The only thing I need is the patient ID. And the way that we see that here is, as I've listed out some of the functional dependencies, is here column A determines columns B and C. So patient ID determines patient name and patient surname. So we don't need. What's that? Oh, okay. So we don't need both A and F in order to determine the patient name. We only need A, right? So what we're going to do is we're going to say, rather than duplicating patient name and surname every time we see patient ID, we're going to create a patient table. And what we'll do is we'll have the patient information like this. So now the patient ID tells me what the patient name and surname is. And in the original table, the only thing I need to keep there is the patient ID. All right. So now, while there is some duplicate, right, the patient ID is duplicated across 2 rows, we no longer have all this other information also duplicated across multiple rows. Okay. So what that also means is that if, for example, for some reason somebody needed to change their name, let's say this is going to change to another name, right? So now we have this this update anomaly, right? Because this only changed in one place, but it didn't change here. So which one of these names is the correct name? Well, we don't know, right? But now here in the second normal form, if we change it here, right? We've only had to change it one place, and it changes for everybody. So every time here, this placebo was given to Perry another name. Okay, we don't have to change it in multiple places. All right. Back. All right, so that's the idea of second normal form, is all of our relations, all of our tables in our second normal form are fully functionally dependent on the primary key. So here, this is our primary key. Everything's fully functionally dependent on that. Here, the combination of patient ID and date given is our primary key. Everything is fully functionally dependent on that. There is no example of a piece of data that that is dependent on one of these, but not the other. Okay, but not the combination of the two. Okay. All right. So that's second normal form. So we're done with second normal form with designing it. All right. Now we're going to talk about the third normal form, which is transitive dependencies. And the idea is similar, but not entirely the same. So full functional dependency said everything needs to be dependent only on the whole primary key and no part of it. Transitive dependency says if there's a column that's dependent on some other column that's not part of the primary key, then I want that to be its own table also. Okay. So the idea here is we're going to duplicate, or sorry, we're going to get rid of duplicated information such as this right here, right? So we're going to try to say, okay, this determines this. So therefore, I don't need to have this thing in my main table anymore. Okay. So just like what we did with the second normal form, we're going to take any combination that exists like this, or a combination that exists like this, and we're going to make it its own table. Okay. So now we'll have a drug table that indicates what is our drug ID. Now the thing on the left-hand side here, thing on the left-hand side, let's see, B determines C. Okay. B, drug ID, that becomes our primary key of our new table. And the other columns, right, they become our data columns, our other columns from our new table. So here, drug ID, drug name gets its own table. This given by ID, given by surname, right, becomes its own table also. The only thing that gets left back in our main table, our original table, is just the primary key copies from here. So the CV1, 2, and PL here, 10 and 12 over here. Notice one thing that we've also been able to reduce is how much data we're storing, right? So here in our original first normal form, where every row column had a data, it was just one big table, right? There was data in 90 cells, so we had 90 cells worth of information. Here in our third normal form, we've reduced that quite a bit to about 67 worth of information. Okay, so the idea here is one, we've reduced our update anomalies. So if something changes, if somebody wants to change the name of something over here, it doesn't have to change multiple places. The other thing is we've also reduced how much storage space we're using for data. Okay. One thing you guys have gotten used to me saying is the word trade-off, and the trade-off, there is a slight trade-off here in that we have more tables, and so there is a little bit of extra overhead that comes with creating these tables. Okay, but in general, as our amount of data starts getting really large, so like in a real life vaccine trial example that researchers would actually use, most likely the data would get millions of rows. And so we would end up having a lot of data that would have to be dealt with. So, all right. So I let's see, where was I? So that ends our just section here on the general definitions and how to get there using that vaccine trial example from from the standpoint of just from the spreadsheet. But I did also want to go through with you guys in a live setting. I wanted to go through with you on how to take that example into a MySQL database and run the queries in order to make it happen. Okay. And then I also wanted to do one other thing today, which is to show you how you would then take those tables, these tables here, and draw them into an ER diagram. Okay, because that's your that's your group assignment, your group project here is, so the unnormalized set of data, right, would be basically what I'm expecting to see from that is I'm wanting to see something that looks like this. Okay, it can look like this. It can be the first normal form. That would be fine as well. But basically, what columns are you maintaining? What information are you getting? And what is some example data that you're going to be using? Okay. As I said, the number of columns needs to be at least 30. The number of rows can be anything. It can. I can tell you that more data helps you identify the functional dependencies better, but more data also makes for a much more time-consuming and difficult to create project. So there's the trade-off there of the more data. So I would say, 2 or 3 rows probably not enough, but I'm not expecting you to have hundreds of rows either. Okay. All right. So the ER diagram, we'll get into that in just a moment after I talk about the SQL queries. Or actually, since I have it as number 2, let's go ahead and just do it based on the this guy right here. So this third normal form. All right. So what you can do is you can either draw it by hand and scan it, or if any of you have ever used draw.io. Okay. Let's see. We're gonna. So I'm going to put it inside of my there's 204. Put inside. Nope. All right. So I should have renamed it something better than untitled. Okay. And I'll share this with you guys so you can see it as well. All right, so draw.io I like using because it has UML, it has entity relation, which is what we're trying to draw, so it's nice, right? So what we would do is we could bring a table in, okay, and we can name our table whatever it is that that we named it over here. So maybe the patient table, for example. And reminder that in entity relationship diagrams, the class name, the entity name is always going to be in the singular. Okay. So we can give it no, not our rows. And you just name it like this. Okay. So now you have a table, right? So we can bring in another table. It's called drug. That was drug ID and drug name, right? Now we can delete that. Okay. And then employee, we have an employee table. And actually we can copy and paste the patient table, and we can just name it employee. All right. So now you have an employee table, a patient table, and a drug table. Now, So what we're doing is, so the question is, do we need the main table? And sometimes you might say no, and sometimes you might say yes. It just depends. It's how you want to draw it and how much detail you want to give to your diagram. Because in some ways, this main table actually represents a relationship, right? It represents a relationship between a patient and an employee and a drug. It's that what they call the not the binary relationship, but the trinary. I'm blanking on the word for it right now, but it was this idea of having these three entities that all have a relationship with each other, and we could say that an employee gives a patient a drug on a certain day, and so in a sense we could just draw this as a three-way relationship between these three tables. That would be fine. If you said that that's what this table represents, then that would be accurate. That would be an accurate way to analyze that. And one of the things we'll talk about in a couple of weeks is how that actually makes a lot of sense. That would be how we would represent a many-to-many relationship. Okay, but for now, just to make things easy, I'm just going to go ahead and bring this main table in, and we're just going to call it a trial, maybe. Just give it some kind of name. Main table doesn't really tell me what that table is, so we'll give it some other name. It's going to have a patient, a drug, a date, patient ID, drug ID. It's going to have a date. And then what was the last one given by? Okay, and then an employee ID, basically. So we have our tables set up, and now we need to identify what the relationships between these tables are. So basically, what you probably have figured out is that there's only relationships between this main table and the others, that none of these three tables here, patient, drug, and employee, have a relationship with any of the others. Okay, so basically what we're going to end up with is a diagram that could look something like this. Okay, and so let's see, and these are our relationships over here. Okay, and so what type of relationship should trial have to employee? So each trial is administered by an employee, right? So, and then each employee can administer one or more trials, right? So we would see this as a one-to-many relationship. So we look for our one-to-manys, okay? Let's see, that's a many-to-many. So we have a bunch of different possibilities here. You have one mandatory to many mandatory that they would be required on each side. Does an employee have to give a trial? I would say no. So let's look for a different one. I think this one makes the most sense, right? Because this is, let's see, I want to put this right. I'm going to put it on. Trying to figure out how to get it on the, that'll work. Okay. Okay. This isn't working out quite as I had hoped, but let's see. There we go. That'll work. That'll be good enough. Okay. So what this relationship indicates is that if a trial exists, it must have been given by an employee, and it's required. It's required on the employee side. An employee is required to have been involved. Now, an employee can give 0 or many trials. So the way that we could also have written this is put a label. Where's my text? I want like a text. Where is my text? Okay. You could also have put it in like this with these lines here. Trying to find the text. They've changed this up since the last time I've used it. Oh, here it is, text. Okay, so you could also have typed it in like this. So 0 dot dot R. Okay. One dot dot one. So this should look familiar to you guys because this is how I drew it in class the last time we got together. Was I would draw it using the numbers notation on each side, where you have a mandatory 1 over here to a 0 to many over here on this side. So the way that we would read this is it's a 1 to many relationship that is mandatory on the employee side, optional on the trial side. You'll probably would also understand that each of these would probably be similar relationships across the board, that this would also be a 1 to many relationship patient to trial. It would also be a 1 to many relationship drug to trial as well. Okay, that a trial has a drug, a trial has a patient, right? Mandatory patient, mandatory drug, and so forth. Okay, so in the interest of time, what I'll do is after this call ends, after this meeting ends, I'll finish this diagram up the rest of the way, and I'll go ahead and post it to the Google Classroom so that you guys can have access to it to see how I finished it off. Okay, because the other thing I wanted to make sure to go through today in more of a live setting was how to take this first normal form table and write the queries that we're expecting to be able to get them into this form over here. Okay, so that's the number 3 here. This SQL queries for creating tables and inserting data. One question I've gotten a couple times is there are some of you that are planning on using a non-SQL database, and that's fine if you want to use a non-SQL database, but you do need to show me then how whatever technology you're using, how it would be able to do this, how it would be able to take data, create tables, insert data from the UNF into the new tables that you created. Okay. So looking at that. Okay, so here I have my table, my UNF table, I just call it UNF, and it's got all my 9 columns. Okay, so what I want to do is I want to go and create my second normal form table first. I want to create that patient table. So what I'm going to do is I'm going to look at the structure. I'm going to look at the structure of the main table, and I'm going to say, okay, these are the 3 columns that I need to copy over. Okay, so I'm going to create the table. Now, if you're using MySQL, you could create a table using just the create table here. You could say I want to create a table, 3 columns, and go. Okay, and then it'll do all the work for you. That's fine, but I do want you to go ahead and at least copy and paste the create table statements that get created there. Okay, so like if you did this, if you said, okay, I'm gonna have a name, I'm gonna have a surname, varchar 20 and 20. If you just do this, that's fine. I've got no problem with that. Use the tool that that you've been given access to, and preview SQL. So you would need to paste this. So you would need to take this and paste it. You would also have to add the primary key constraint. Okay, so if we save that table, okay, so now I have the table created. It has no data in it. I want to make ID the primary key constraint. So you would need to also paste this in. Okay. There is also a way to do that using the create table statement alone. You can add the primary key constraint at the end alone with just one single create table statement. It's fine if you show me that as well. That's another way to do it. But this is what I need, is that if you do it using the user interface of MySQL like this, the PHP myadmin interface, then I need you to copy and paste those create table queries and copy and paste the alter table primary key as well. Okay, so now we want to populate this table. We want to put data in there, because if we look at the data that's there right now, there's nothing there, right? So what we need to do is we need to take the data from here, and we need to put it into here. Okay, so we want to insert into patient. So enter into patient. I'm going to go ahead and take all of this off, because we're not going to use that, because I'm not going to insert this value by value. That would take a long time, especially if we were dealing with something where we did have hundreds or possibly thousands or millions of rows from our main table that we were trying to bring over into a second normal form table. It would take a long time to enter all that data, right? So what we would prefer to do is we're going to select from our UNF table, and the reason why I did that first is, you'll see why, because now I have access to all of these other columns, right? All right. So I'm going to insert into patient, and I'm going to get the data from the UNF table. Now, if I click go right now, it's going to give me an error, right? And the reason why is because there's a duplicate entry on the primary key. One thing I had said to you guys, sometimes what might not be a bad idea would be to run the query that you expect to see. Okay, so you run this query, right, and you see that it got all the data from that table, but this is not what I'm expecting to see over here. I'm expecting to see no duplicates, right? So we can use the distinct keyword in order to make that happen. So if we say, give me the distinct information from that UNF table, okay? Now it should work. 5 rows inserted. If I look into the data in the patient table, there it is there, okay? And that seems to be correct. So if I look in the UNF table, it's still there though, right? This information is still there. That's become not the place I want to keep it anymore. I don't want this information. I don't want this data over here anymore. I need to get rid of it out of that UNF table. So how do we get rid of that column? Well, a couple of possibilities. One, if you use MySQL, you can just click on these two columns, and you can just click, or you can click on drop for that column, or you can click on the drop down here. Okay. Now, do you really want to execute the following query? Because what is this going to do? This is going to alter my UNF table. It's going to get rid of my patient name column. It's going to get rid of my patient surname column. Now, for this example, I can do this, right? Because I know that this information is now stored in another place. It's stored in the patient table. Be careful with this, because remember, as we talked about, the drop the column gets rid of the column and the data inside. Once that's gone, you can't get it back. Okay. This would be another thing that I need you to copy and paste into your group submission report. All right, so that we can see how you modified that UNF table to make it what we expected to see. All right, so now the UNF table no longer has that patient information. And why? Because now it exists over here instead. Okay, so now it looks like this. Perfect. Okay, one other thing we can do is we can alter a table. We're going to alter the UNF table. Okay, we're going to add the foreign key for let's see, patient ID, references, patient is what we named our table, ID, right? This should work. Good, so we altered our table. Another thing I would like you to include in that report. Okay, so now if we go and we look at our UNF information, notice that now patient ID now is a link here each time, right? So if I go and look at what patient ID, if I click on 123, I now get that row from the patient table, from the table that it references. So that's a pretty cool thing that MySQL gives us access to. Okay, so we have our two tables here. Let's go through and do a couple more, do the drug table. Okay, so now we're going to create our drug table. So I'm going to do it using the SQL this time. Create table drug. Okay. And it's going to have what, an ID column that is a varchar. I think I made it a 3, right? And it's going to have a name column, also a varchar. I think it's 20 though. Okay. And I'm also going to give it a primary key. Of the ID column. Okay. So now in one nice SQL statement, okay, I created the table, drug, and it also has a primary key defined all in one. Rather than trying to do it through two separate, rather than doing it as a create table statement followed by an alter table statement, here I just did it all as one. Okay. Same thing as before. I'm going to run my SQL query to insert using the data from the main table, right? From the UNF table. So now I want get my drug ID and my drug name. Okay. Oh, almost forgot my distinct. Okay. So I've inserted that, right? And then I'm going to also go ahead and create my employee table also. This one I'll do using the user interface again. Because it has a similar structure to the patient table, this should not be so. A lot of this stuff in my text field should already be saved, should be cached in there. add my primary key constraint here. Okay. All right, so now insert into employee, select distinct, UNF. What do I want? I want the given by ID, given by name, and given by surname. All right, so if we look through our data that's in these different tables now, it should look exactly like what we have in here, right? So that's correct, that's good. And then our employee table should be just the two of them right here, right? Correct. So now the only other thing that we haven't done is the UNF table. Is we should now need to drop some of these columns, right? Now, be very careful when you go to drop these columns that you're only dropping the columns that are not primary keys of the other table, okay? So what you want to do is from the drug table, the drug ID is the primary key. You want to drop everything else from the drug table, okay? The given by ID, the ID of the employee, that's the primary key from the other table. So you want to drop the other columns from there, okay? So when you drop, okay, you would highlight this, copy and paste it, all right? Okay, and so now we have these here. We would then run that alter table, you know, we're adding a foreign key for drug ID references drug ID. Okay. And then one more thing, we would add, I think it's called given by ID. References employee ID. And that should work. All right, so if we go back to our UNF table now, right, so now notice all of these have become links also because they reference the other table. Okay. All right, so I think that's it. Right, so we've gotten our situation where this looks like this. One thing I think you can do, I don't think you can here in the MySQL. What you might want to consider doing is when you go to actually make this into a database into MySQL after you've designed it in some other tool like a spreadsheet like this, is maybe give your original UNF table a more meaningful name than UNF because that we don't know what that is. So maybe name it something from the start, something like trial, for example. Okay. All right, so I wanted to walk through how to do that with some examples. As I said, when this meeting is over, I'll go ahead and finish this diagram up and post it as an image to the class, the Google Classroom. But I just wanted to make sure to kind of go through this example in more of a live format so that you guys could see as I go through how this works. Okay, so are there any questions? Are there any questions about what we went through here? I can put my camera on. Because if not, then we can call that a day, and this recording will be posted to the classroom stream. Once it's done processing, it'll take a video of this size. Will probably take a good 20 minutes or so for Microsoft to process it and post it. So if there's no other questions, then we'll go ahead and end this meeting here, and I'll see you guys on Thursday. Okay. All right. Have a good week, and I look forward to hearing from you if you guys have any concerns or need some more information about what you're expected for your group project. All right. Have a good afternoon.